Hey, today's episode of Broke Dad Builds. Do you want to know how to use a meter just to test circuits on your car or truck or your project? If you want to know all the basic stuff, follow along. All right, so let's get into it. This is a multimeter. You can use it for things, mainly testing circuits, testing voltage, resistance, things like that. So for today's lesson, we're just going to go over how to test for voltage. For this one, I have a flute meter. These are really easy to use. They're really reliable. I've had this thing for probably 20 years almost, and it works really good. You can see it says Lincoln Tech. Yeah, I went there a long time ago just because I wanted to go to school. Anyways, for this instance, for today's lesson, we're going to put it on voltage. So you got a couple options. You got AC voltage for checking alternating current, mainly, that's going to be your outlets, things like that. And then DC current, direct current. So it's going to be your battery supply on your car or truck, 12 volts, 6 volts, 24 volts. So for today, we're going to go with that. There's a millivolt option. There's a resistance option, which is this little horseshoe icon. This is continuity. So if you test or connect the probes together, diode, and then current test. All right, but we're going to go with DC voltage. So for all your power supplies on your cars, you're going to have a positive and negative. Red, positive, black, negative. You all should pretty much know that, right? Pretty basic. And then for your leads, you're going to have a red lead and black lead. You're going to have a red. Let me get in the picture. You're going to have a red lead over here and black lead on the common. And then for current, we're going to do current tests. You'd put it in over here for the red lead. So, but for this instance, we're going to do voltage, and we're going to have the negative on the black. And with this in DC voltage setting, we'll put this on the positive, this on the negative. For this case, we have this power supply right here. This will represent our battery for this instance. So this is an inverter power supply. So it outputs 12 volts. I use this for checking circuits and testing out different things where I don't want to use a 12 volt battery. It works. So for this, let's pretend this is our battery. We have this red wire coming out of it that will represent our positive on the battery, and this black and red, which will represent our negative terminal. So when you're checking a battery, you could check it just for static charge and see what it is, right? So the meter will show you the voltage output. For this instance, 12.35 volts. So that's how you do a simple test, checking voltage. Now you're like, oh, well, bro, what do you want to do now? Like, what if I want to do other checks? Like if I want to check a circuit, like voltage drop, and maybe see how much voltage is being used by a load, which in this instance, we have a light bulb. That is our load. A light bulb, a motor, actuator, those are loads. They consume voltage, right? So for this case, we have our 12 volt power supply. We have a light bulb, and we also have an energized circuit. Ooh, it's bright light. All right, so it's a little too bright. but you get the drift. So with an energized circuit, we'll just say it's energized. You're going to check, oh, right way. For a circuit, put on the negative, and you're going to take your positive and put it on the positive side of the circuit. So for this instance, this wire that I have right here, this is the 12 volt positive cable. So we got voltage up to that point, right? And once we connect it to the positive wire on the light bulb, we will have voltage up to the point of the open on our circuit. So for this instance, we have our ground cable, or ground wire, excuse me, for the light bulb. It is not a closed circuit yet, it's an open circuit, so we're going to have voltage up to the point of the open, which 12.35 volts. So keep that in mind for when you're testing a circuit, you're going to have voltage up to the point of the open. So if you're trying to find like an open circuit, if there's something that's not working, have a good ground, which is your battery is going to be your best ground to use. You can use chassis ground, but there's always opportunity where you can have resistance build up, at the connection point on the chassis, right? You can have a ground wire that might be corroded some, and that causes excessive resistance, and that will actually cause a voltage drop. Resistance will use voltage. Keep that in mind too. So if we're going to use a known good ground, use your battery negative terminal for the known good ground, and then you're going to take your positive probe, and you're going to go across the circuit and check for voltage up until you get an open. So we had positive voltage, battery voltage on the red wire going to the bulb. We have battery voltage going up to the ground wire after the bulb. And then if we check the ground wire itself, going back to the power supply, then there's our 0 volts. That would indicate an open between this wire and the ground. So that's kind of just a quick and dirty run through of checking for open ground for circuit integrity. If you want to check voltage drop, you're going to check voltage across a load, right? So let's say this, I'm not going to energize it right now because it's too bright. But if this is energized, that light bulb should use almost all the voltage, right? If this is a perfectly good light bulb in a perfect circuit with no resistance, no corrosion on the ground side or corrosion or on a connector on the positive side going to the light bulb, your light bulb should use almost all of that voltage that's supplied to it. Remember, like I said before, resistance uses voltage. Corrosion and all that will use some voltage. You do have some voltage drop across circuits, usually 0.1 to 0.2 volts across a circuit, depending on the diameter of the wire and the length of the wire. But for this instance, we're just going to focus on the easy stuff, and we're just going to say if we have 12.3 volts at the battery supply, the power supply, the light bulb should be using close to that, or almost all of it, right? So you're going to take your meters and you're going to go across the positive and the negative to the light bulb when it's energized. And you should see most of the voltage that's supplied should be consumed by the light bulb. Maybe I can actually energize this really quick just to show you. So if we do a closed circuit, .2 volts, right? So there's about 0.2 volts that's being dropped or consumed elsewhere. So that could be the wires, that could be, like I said, a corroded ground, which I do have a rusty piece of metal in line with the ground side circuit that goes to this. So that corrosion, that rust on the ground side will consume a little bit of voltage. This is crucial for when you're doing circuit checks for engine controlled components, sensors, especially sensors and your ground circuits for the PCM. If you have any excessive resistance buildup on a ground circuit that is part of the PCM connection for the PCM ground, that can cause wonky issues, could cause error codes to pop up, as well as with your sensors. If your sensors start getting corrosion on the connectors, on the ground side circuit, that can cause excessive voltage drop, and it can cause your readings going to the PCM to be skewed because it's not getting all the voltage. It's not getting the correct voltage back on the reference signal. So I hope this helps. Hope this is a quick and dirty run through. If you like this, let me know. I'll do more content going over voltages and circuit tests and things like that. I got a lot of information I could share, and there's a lot of information on the interwebs. So just take your time, learn this stuff. If you got a meter, play with it. Learn all the settings. Just remember, don't check voltage when you're on resistance. That'll let out the magic smoke, and you can't put it back in once it comes out. Hope you like this. Subscribe, like, share, do all the things. Leave me feedback. See you next time.